Hello, my dear student. I welcome you all to the maths class. So, in our last class, you all know that we have completed our chapter number 4, simple equation, right? So, from today onwards, we are going to start a new chapter, that is chapter number 13 from your NCERT book, that is Exponents and Power. So, over here, before starting exercise, I would like to introduce few things which are very important, basic rules, right? In class 9, 8 and 10, these things are very important. Okay, and then I'll be starting with question number 1 of exercise 13.1 after the introduction part. Okay, so first, so I would like to request everyone, each and everyone, the one who is watching here, who is watching this video, kindly go through the video till the end. Okay, so let us start our class, starting with what is exponents. So you all have heard this term exponent when you're in lower class, right? So in today's class we will discuss about this in a more brief, more idea, we will take the more idea about the exponent. Okay, an expression, what are exponents? An expression that consists of a repeated power of a multiplication of the same factor is called as power or exponents or indices. The term which are used in place of exponents are power and indices. So in an expression that consists of repeated power of multiplication of the same factor is called power, exponent or indices. We can also say that the exponent state the repeated multiplication of the same number with respect to the number of the time. Suppose here you can see the example 2 cube. So 2 to the power, the way of saying it is 2 to the power 3. 2 to the power 3. Here 2 is the base. Here 3 is an exponent or power. So if you are saying total whole, then you have to express it as 2 to the power 3. And what is exponent? The exponent state the repeated multiplication of the same number. So here 2 cube can be written as 2 into 2 into 2. So 2 cube means the 2 base is repeated or multiplied with the same number 3 times, right? So this is the exponent, this is the power. So if only what is the, if suppose somebody asks you what is exponent, then exponent is 3. Okay, so if you have to express this in your word, then you will be expressing it as 2 to the power 3. So there is a difference between exponents and power, we will come to know later on. Okay, so the exponents state the repeated multiplication of the same number with respect to the number of times. Okay, suppose you have 5 to the power 4. So if you have to express this in your word, then you will be saying 5 to the power 4. Now if you have to find the value, then you will be repeatedly multiplying with 5 4 times. 5 5 5 5 4 times, because our power or the exponent is 4 here. Okay, so this is the basic funda. So here is the example. So 5 cube, 5 to the power 3 is expressed 3 times multiplied with 5 itself, which is actually representing an exponent. Okay, and here this 3 is an exponent. Now knowing about exponent, now the question arises, what are the difference between the exponents and power? So what is power? Power refers to the whole expression. Suppose say 2 cube, 2 to the power 3 or 2 to the power 4, then this whole is a power. Okay, so refers to the whole expression representing the repeated multiplication of the same number. Say 2, how many times it will be multiplied now? 4 times. So this is a power, that is an expression in which the numbers will be multiplied with itself. What is the what is the number of time it has to get repeated? That is a power. That means the whole expression, Now exponent, what is exponent then? So exponents are, it represents the number of times the base is used as a factor in multiplying itself. So if 2 to the power 4 is a power, whole is a power expression, then only 4 is an exponent. So that means exponent will represent how many times the base number will be repeated, base number will be multiplied itself to get a product. Okay, so power is nothing, power is a whole expression, and exponent is a number which actually represents that how many times this base has to get multiplied with it used as a factor in multiplying itself. Okay, so example here I can show you here. This is showing for the power and this is showing for the exponent, number 2 point. Okay, so this is the first point I have shown you all, this one, and this is the number 2 point. Okay, what is number 2? What does number 2 point says? In 2 cube, this is 2 to the power 3. So 2 is repeated how many times? 3 times, right? Is the base number which is to be multiplied by itself thrice and could be also called as 2 to the power 3. So we will say 2 to the power 3 for a power, because power is 4, right? And in now in exponent 2 cube, 3 is the exponent. Okay, so in similarly here what I have shown you, 2 to the power 4 whole is a power in which the base number will be multiplied itself thrice, or 4 time or 5 time, whatever the number is, could be multiplied. Now in case of exponent in 2 cube, the 3 is the exponent, which represents the number of times 2 is to be multiplied by itself. Okay, so power is nothing but a whole expression, and exponent is the number in which the base number should be multiplied with itself to get the product. Okay, so these are the difference. All right, now if you understood what is exponent, then you know that in every form of a match you have a law, you have a rule, right? You have a rule. Without rule, no maths can be solved. Even to do the addition you have a rule, even to divide you have certain division rule, even to multiply you have certain division multiplication rule, right? So for every calculation in a mathematics you need to have a rule. You have a rule. Okay, okay. Now similarly for the exponent, for this exponent context also we have certain rules. So the rules which are given here are first, second, third, fourth and fifth law. But these are very easy, very understandable. I hope you people will understand it. So let us discuss about the first law. So I'll be writing here the first law. I'll be showing you the example. Okay, so in first law what it says is, what it does is, suppose when you have the same base, a to the power m, a to the power n, right? You have the same base, just have a look, and when you have the same base and multiplication sign is there, then the power will be added. Okay, so let me write here, if you have same base, no matter what is the power, your power may be different, your power may be same, it doesn't matter, but we are just concerned about the base. This is the base, I have already told you, and the whole expression is a power, and the only m and n is an exponent. Okay, so if you have the same base, and multiplication sign is there, and if multiplication sign is there, then exponents should be added. Okay, so when you have the same base, right, and if multiplication sign is there, then the exponents should be added at that time. So what we have done here, this is the funda here. Okay, so this is the first law. All right, so you may have a two number. Sometime you may also have more than two number, that is, suppose say a into m, a into n, a into p, a into r may be there. So but the same rule will be applied, that is, when you have the same base, the powers are going to get added. And if there is a multiplication sign, remember there should be same base, and another important is you should have the multiplication sign over there, then your powers, then the exponents are going to get added. All right, this is the thing. So let me show you one example here. So example for this, suppose you are multiplying 2 to the power 3 and 2 to the power 15. Here in such case we are not able to multiply directly and get the value. 2 cube, it's okay, we can get the 8, But what about 2 to the power 15? You have to go for a long calculation. So in such cases, we will be using the exponential rule. That means when you have the same base 2, write one base there and add the power. And also remember, you have a multiplication sign. That is which rule we have applied just now. That is the first law or the first rule of exponent. That is when you have the same base and if multiplication sign is there, then the power should be added. So 2 to the power 18 will be the value. This should be the answer. So this is the example I've given here. You'll see many variety of example. Suppose say 2 to the power 6. Suppose you have 5 to the power 2 and 5 to the power 5. In such cases also you have the same basis. You have the same base 5. The exponent should be added. 5, 2 plus 5 is 7. So the value is 5 to the power 7. So this is called the exponential form. This is the way of representing using the rule of exponential powers. Okay, next, second law. Now what if you have the same base? Rule number 2, I'm talking about second law or second rule. What if you have the same base, different, maybe same power, different power, no matter, but you have the same base, but in place of multiplication sign you have a division sign? What if the condition is there? Then if such is the condition, what happened in the previous form, that we have added. Whenever there is a multiplication sign, then that adding should be done. But whenever you have the exponent different or same, no matter, but base same at that time, and if division sign is there, then subtraction should be done. Okay, so let me write the rule number 2 here. If you have same base, if you have same base but multiplication sign is there, then exponents should be subtracted. Exponents should be subtracted. Okay, so when you have the same base but, okay, sorry, here I have written multiplication sign. It should be division sign, but division sign is there, then exponent should be subtracted. Okay, suppose example, you have 2 to the power 5 divided by 2 to the power 7 or 2 to the power 2. You have the same base, no matter whatever is the exponent at that condition, and there is a division sign also, then we will go for rule number 2. That means 5 minus 2 should be done. The value will be 2 cube, which is 8. Okay, so this is the thing. Alright, now let's proceed to the third rule. So third rule state that whenever you have power on power, say for you have power on power, we are doing rule number 3 or law number 3. So law or rule number 3 state that whenever you have power on power, power over power, sometime you may have power over power, then at that time power should be multiplied. That is m into n should be done. Okay, don't have to worry on such cases. Suppose I'll show you the example. 2 cube to the power 2 if you have. You may have such conditions also. Alright, you may have a positive sign, you may have a minus 2. At that time what you are going to do? 3 into minus 2, 2 to the power minus 6 will be the value. Or if suppose you have 2 to the power 5, 2, then you can write 2 into 2 to the power 5 into 2 will be 2 to the power 10 will be the value. Okay, simple thing. So let me write the rule number 3 here. If you have if you have power over power or exponents over exponents, let me write power only, it's not a problem. If you have power over power, then exponents should be multiplied. Exponents should be multiplied. I hope till now you understood what is power, what is exponent, what is base, right? So the base here is stand in the ground level and the exponents is at the top of its head. So if you have power over power, then exponents should be multiplied in such case. Okay, so this is the case. So a to the power m into n will be represented as a to the power m into n. Okay, so or it can be written as n into m also. Both are similar because commutative rule I hope you all know. Yes, 2 into 3 can be written as 3 into 2 also, because we are going to get the same product, right? So this is third rule, nothing but a third rule. So what is fourth rule then? Fourth rule says that when you have different base but the same power, sometimes that may be the condition. So let me write the rule number 4 here. The rule number 4 state that when you have the same base, when you have different base but same power, okay, remember the same power, and at that time what will happen? That means you will write the one power, that means all the bases will be multiplied in such cases. So like it is taking a common. So power, in such case only one power should be written. So let me give an example here. Example, you have suppose 2 to the power 3, 3 to the power 3 and 4 to the power 3. Just see, you have different base but all the exponents are same. All the exponents are same. So in such condition, all the bases should be multiplied and should be written only one exponent on its head. That is 2 3 is 6, 6 4 is 24 to the power 3 should be written like this. It should be represented like this. Okay, so this is a very simple thing. So this is nothing but a rule number 4 in exponent. So if you have different base but different base but same exponents in all base, then bases should be multiplied. Bases should be multiplied and one exponent should be written. Isn't it? So you just saw an example also that whenever you have the different base but same exponent, and at that time you will be multiplying the bases, only one exponent should be written at that condition. Okay, so the last and the fifth law is left out. So it is also very, very similar. So let me solve it over here only. Let me discuss about this law. So this law states that whenever you have the in exponential form like this, a to the power n by b to the power n, that means the bases are different, right? The bases are different but the powers are same, and in fourth law I forgot to mention that there is multiplication sign also. There is a multiplication sign, but if you have division sign in such case, then only it should be written like a by b to the power n. Okay, so this can be written. I request you all to write this a to the power n divided by b to the power n in this form only. Then you can write one power like this, a by b to the power n. Suppose you have 2 to the power 3 by 4 to the power 3, then we can write 2 by 4 to the power 3. It will be very easy for you all to solve. Then you can solve 2 1s are 2, 2 2s are 4, 1 by 2 whole cube means 1 by 8, isn't it? So just saw that whenever the bases are different and if there is a division sign, then the exponent should be written 1 at that condition. Okay, when you have the division sign. So this is the condition, these are the rules. I hope you people understood. What are the exponents, powers, the difference, and the laws. The fifth law, 5 law we have stated right now, we have learned till now. Now let us do exercise 13.1. So if you people have gone through that introduction video properly, then you people will not face any problem to solve this exercise. So the question number 1 here we have is, find the value of 2 to the power 6. What is the exponent? An exponent here is 6, right? An exponent here is 6. And what is the way of expressing? The way of saying it is, it has 2 to the power 6. Okay, so let us find the value. So you know that whenever what is exponents actually represent? Exponents actually represent that the number, okay, the base, whatever the value of the exponent is, that number of time the base should be multiplied. So 2 to the power 6 I can write like this: 2 into 3, 4, 5 and 6. 1, 2, 3, 4, 5, 6. That means it is that this number is multiplying with itself 6 times, right? So this is nothing but an exponential power, exponential value. So 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32, 32 to the 64. So this is the value of 2 to the power 6. Okay, so I hope you people got it. Similarly, 9 cube can be written as 9 into 9 into 9. 9 9 ja 81, 81 9 ja 729. Yes, 729. Okay, so I hope you people understood. This is the way of doing. Similarly, here we have in the next part, that is question number part 3, 11 into 11. 11 square means 11 is multiplied with itself 2 times. So 11 11 is 121. Right? 5 to the power 4. So 5 to the power 4, I want you all to do it yourself. This will be a home assignment. Kindly do it. And I request everyone to go through this video again. You may be having a problem anywhere. So if you have a problem anywhere, please feel free to share with me. Okay, so this much for today, student. In our next class we will proceed with the next sum. Till then, stay safe and healthy. Thank you everyone.